Hi, everybody. Today we're going to talk about Ethereum 2.0. And my name is Ozer.
And my name is Akhila, Raju.
And we both work at PegaSys. And PegaSys has a Ethereum 2.0 implementation on its way. And we're Ethereum 2.0 engineers building out implementation. Today we're going to go over why we need Ethereum 2.0, problems with Ethereum 1.0, and then how will the system Ethereum 2.0 work.
Okay, so first we're going to start with an overview of Ethereum 1.0 and why there's a need for scalability. So on this graph, we have block utilization on the y-axis and time from mid-2015 to mid-2018 about. And this is basically usage of the network over time. And as you can see, towards the end of 2017 and through 2018, it's almost at 100%, which means that the network is getting overloaded. And what this can mean is that it can cause undesirable user experience issues such as lengthy wait times for your transactions to get included in the blockchain and volatile transaction fee or gas prices. So currently on main chain, we're able to process 15 or so transactions per second, but we want to be able to process thousands of transactions per second.
So other than the scalability problem, we have a couple of problems with proof of work. If you don't know, proof of work can kind of be said is the main innovation of Bitcoin. It's basically the state update block proposal mechanism. It allows us to update the system so that we can include more and more transactions as time goes on. The way it works is pretty simple. Miners, who are the people who secure the system, race to solve a energy-intensive cryptographic puzzle, and whoever gets to solve this puzzle first is able to produce a block, and when they produce a block, they're able to earn a block reward, and as a result, they make money, and that's how they're incentivized to secure the system. In proof of stake, on the other hand, anyone can stake money to become validators, and as they become validators, they are randomly chosen to produce blocks.
So there's a few issues with proof of work. The first issue is that it requires a lot of energy and money to solve the cryptographic puzzle, so it's really monetarily and energy inefficient. Specialized hardware is cheaper when bought in larger quantities, which incentivize miners to centralize through ASIC farms economies of scale. And there's no penalties for bad actors, so bad actors are not penalized for malicious behavior.
So now that we kind of introduced the problems of Ethereum 1.0, we're gonna dive deep into Ethereum 2.0 and how Ethereum 2.0 is trying to solve these problems. So here Ethereum 2.0 is a way more complex system than Ethereum 1.0. Instead of having one chain, Ethereum 2.0 is composed of thousands of chains. And if you look at it from a bird's eye view, it is a hub and spoke model where a hub chain, a system chain, and we will call it beacon chain from now on, sits in the middle, and it manages everything system related. It applies proof of stake to its validators, manages validator rewards, penalties, and then provides randomness to the rest of the system. It's all it's also the hub that allows these spokes around it to communicate. And around this hub, we have shard chains. Shard chains are where user transactions take place and account data is stored. And each of these shard chains are similar in capacity to the Ethereum 1.0 chain we have today. So the number of shard chains is kind of variable, but currently it's set to 1,024. And if we imagine there to be 1,024 shard chains, we can imagine Ethereum 2.0 having 1,000 times the scalability of Ethereum 1.0 we have today. And then on top of the shard chains, we have VMs, execution layers, and those will be used to execute smart contracts as we have today.
So this is the speculative timing for each of the phases of Ethereum 2.0 published by the Ethereum Foundation. So we currently have the main chain, which is a proof of work chain. By this year, we're hoping to have the beacon chain implemented. By next year, we're hoping to have shard chains implemented. And then by 2021 would be the VMs.
So how will beacon chain start? It's pretty simple. Living on the Ethereum 1.0 chain, we have a validator deposit contract, and anyone who deposits 32 ETH becomes eligible to become validators. and all the beacon nodes, like the basically clients for this like beacon chain, running like the beacon chain software, will be listening to this like validator deposit contract, and like as this like contract passes a certain threshold of ETH that it like has hold or like burned, the beacon nodes will start running the beacon chain at the same time, and that's how will beacon chain start.
So each validator is randomly assigned to what we call a committee, which can consist of anywhere from 128 to 4,096 validators. And together, these committees vote on what they believe is the latest block of the blockchain.
So in Bitcoin or like Ethereum, like in like proof of work systems, like the system is driven like based on like probability. Like the system can be updated in 1 second if miners solve like the next puzzle in 1 second, or it could be solved in like 30 seconds. The average is like 15 right now, but like Ethereum 2.0 is a bit different. It's a time-driven system, and there's this time concept called like slots. Every 6 seconds, a slot occurs, and a block producer produces a block and publishes it at the start of each slot.
So 3 seconds after the slots start, validators from a randomly chosen committee publish attestations, which can be thought of as votes on what they see as the head of the beacon chain. So if everything goes as expected, that should be the latest proposed block.
These attestations have like multiple roles in the system, and first of all, they contribute to the fork choice. And by fork choice, I mean like we all have probably heard of like forks occurring in the system, people not knowing which like chain is like the canonical chain, which is the like longer one. And these attestations are used as kind of votes, as like what validators see as like the head of the chain. And so in the protocol itself, we can see like which one is like the actual canonical fork, and continue building and working on that. And then also, attestations also contribute to finality, and we haven't really introduced the concept of finality, but basically it is the concept that we're not going to be like, it's going to be impossible to revert blocks, to revert your transactions, unless someone gets like economically incredibly like burned, totally slash their deposits. So it's economically very expensive to like reorganize the blockchain. And lastly, these attestations will be used to allow like the shards that we said in the hub and spoke model as like the spokes, these shard chains to communicate between each other. And we're going to get into detail of how that works.
So Beacon Chain runs proof of stake and provides finality through Casper FFG, but there are ongoing discussions about switching to Casper CBC. Casper CBC is able to provide faster finality guarantees and requires fewer validators.
But like regardless of the specific consensus algorithm, Beacon Chain will have finality, and by that we mean unless more than 1/3 of the validators act maliciously, it will be impossible to revert blocks.
So in the case that more than 1/3 of the validators do attack the chain, honest validators will be able to provide what we call fraud proofs. Fraud proofs are basically receipts that prove a validator was acting maliciously. And with these fraud proofs, we can slash the attacker's deposits and also disqualify them from being a validator in the future of and participating.
So basically, in the system, we're incentivizing people for like participating correctly, producing blocks attestations correctly, and then we're disincentivizing them, like penalizing them for like acting maliciously.
So in this diagram, we show how proof of stake interacts with sharding. So on the top, we have the beacon chain, and on the bottom two chains, we have shard chains. And on the latest block of each of the shard chains, we show some validators who are validating those latest shard chain blocks. So validators are not only assigned to committees on the beacon chain, they're also assigned to some shard chain. So they simultaneously attest on beacon chain blocks and validate shard chain blocks. And the beacon chain keeps track of the latest block for each of the shard chains.
So how does like beacon chain keep track of like the latest block in each shard? It's like through attestations, as we kind of like touched on before. Attestations include this like cross-link info, and by that I mean like just like validators attesting on like a specific shard chain include information about the latest block on that shard chain. And when these attestations get included in the beacon chain, beacon chain gets to learn about the state of shard chains. And later on, when these beacon chain blocks get finalized, as a result, shard chains get finalized as well. And when the system and shard chains are finalized, shard chains are able to communicate through finalized blocks.